Welcome back. The reactor plant is now ready to commence warm-up of the primary circuit. All the permissive have been met and we can start the electric heater elements. Note that all heater elements start initially but will later turn off or on to control the temperature at set point. Primary coolant temperature has started to rise. As the primary coolant temperature rises past 100 degrees, the pressure will also start to rise and follow the saturation curve, at least for the water near the heaters within the pressurizer. Primary coolant in the rest of the system will lag a number of degrees behind the saturation curve. This process is rather slow, but in real life it is slower still. We can skip forward as this may take some time. As the temperature and pressure increases in the primary circuit, it will also start to heat the secondary circuit of each steam generator. We need to exceed 20 bar pressure to enable the first reactor coolant pump to be started. When starting this pump, firstly, the seal water supply valve will open. This seal water is supplied from the charging pump of the chemical and volume control system. Seal water is required to minimize leakage of radioactive primary coolant from the pump seals. When the reactor coolant pump starts, the flow in that reactor loop will rise up to nearly 4,000 kg per second. Go ahead then and start reactor coolant pump 1. Check the pump operation. All looks good. Now, with a reactor coolant pump running, we no longer require the residual heat removal pump in service. Go to the residual heat removal page and stop this pump. Start reactor coolant pump 4. Start reactor coolant pump 2. Start reactor coolant pump 3. The temperature and pressure increase of the primary circuit coolant is still in progress. At the emergency cooling water system page, we need to wait until the primary circuit pressure is greater than 142 bar, and we can then open the safety injection isolation valve. As we get to operating pressure and temperature, the heaters in the pressurizer will automatically back off to 25%. Now is a good time to check the reactor start permissives to see what other systems are still outstanding to place in service. All reactor SCRAM reset permissives are now met. Do another check at the criticality estimation page. We get the same result. 2,455 parts per million. Current primary circuit boron concentration is 2,523 parts per million. We can select the chemical dosing speed to fast and set the dosing set point to 2,455 parts per million. Select dosing on, and the chemical dosing system will now work to bring the actual boron concentration in the primary circuit to the value entered as the set point. In this case, the actual is higher than the set point, so the system will dilute the primary circuit coolant until the values match. Diluting is the term used for lowering boron concentrations, and borating is the term used for increasing them. Boron concentrations are at set point and all reactor SCRAM reset permissives are met. We are ready for the reactor to go critical. This will be covered in the next video. This has been a training video for the nuclear simulator application programmed by Richard Smith.